use your. Okay.
Thank you. Hi, my name is Paulina. I'm majoring in mathematics, and I worked on the project PDB Clean V2, a Python library to curate molecular structures. I interned at the Michael Levitt Lab, and I worked alongside my mentor, Fatima. So to start, we're all made up of atoms, and the arrangement of atoms is what structural biologists want to know. Here we have the protein TIM, which every living organism has, and we're able to see each individual atom in this conformation. However, we can simplify it into a ribbon visual for clarity. So proteins have vital roles, like the protein hemoglobin in blood cells, which transports oxygen. Here you can see the oxygen atoms being carried on each heme group. And then moving on, all data used in the PDB Clean and the 3D structures used previously come from the Protein Data Bank, PDB, an online database that stores 3D structures of proteins and other molecules. The PDB allows scientists to share and analyze molecular data, and each molecule in the PDB has its own ID. So, and then we move on to the zip file. It's a text-based format which stores data for each chain's identifier and the 3D coordinates of its atoms. The zip file is downloaded from the PDB. The zip file is structured such that each row represents a single atom in the 3D structure. The red section indicates the chain ID, which identifies the chain that the atom belongs to as assigned by the software during structure determination. The green section provides the XYZ coordinates of the atom, while the orange section shows the chain ID assigned by the author, aka the scientist who submitted the data. So for better understanding, we can view the information of atom 1 right here. It's highlighted in the purple box. In this structure, atom 1 is in chain A within the XYZ coordinates, these XYZ coordinates in the green box. And then, but it could also be assigned to chain O right here. So the main issue is that different authors can assign different chain IDs, such as naming chain A as chain O, and may use different numbering systems for atoms. This lack of standardization complicates the analysis of larger structures, leading to confusion and making data analysis more time-consuming and discouraging for researchers. And the reason why this matters is because there's too much knowledge to be gained from this data analysis. This inconsistency not only hinders the efficiency of data analysis, but also limits insights that could be used in the field. And then the way PDB Clean helps is that it tackles this problem by saving time, making it easier to compare different structures, and some knowledge can be gained by doing so, since now that it takes less time for analysis, researchers could feel more encouraged. This is particularly important because better data contributes to advancements in potential scientific discoveries, and consistent data encourages analysis and comparison of structures. So the overall research project goal, which is also listed in the GitHub repository, is to have PDB Clean serve as a tool with which researchers and scientists are able to use to create their own self-consistent structured data set, enabling more straightforward comparison among structures. When I joined the group, the code already worked for curating structures efficiently, but it needed improvements in coding practices in a repository organization. During my internship, my main goal was to prepare the PDB Clean V2 repository for code review by addressing code redundancy and removing unused functions to enhance maintainability, clarifying the code logic by removing scattered and commented out sections, and providing proper documentation, particularly by adding doc strings to functions to improve understanding and maintenance. There were several steps I had to take before I could accomplish my goal. Like, I had to do, my first week was basically a biochemistry crash course, since it's been a while since I did anything related to that. And then I had to familiarize myself with the zip files shown earlier, and then I had to learn GitHub. GitHub is a collaboration platform for code, and the repository for PDB Clean V2 is found on GitHub. Then there were Jupyter notebooks. I had to learn this because the tutorials for PDB Clean were on Jupyter notebooks. And for context, Jupyter notebooks are a web-based notebook environment which combines basic code with text. I had to complete the tutorials myself to understand the goal we were building towards. And then there was Python, the primary language of the whole project. It was utilized for coding, debugging, and improving the code base. And then lastly, there was a terminal, which I had to learn, which is a command line interface that allows users to interact with their macOS system through text-based commands. It was used for running scripts from PDB Clean and interacting with the zip files. Here is my workspace during these 10 weeks. So one of my tasks was code cleanup. Here, everything in gray is either commented code or functions that aren't being used anymore. They were creating basically clutter. I would go in and remove everything in gray throughout the code, making the code easier to navigate. And then here is the docstring I wrote. To explain what a docstring is a brief description within a function that explains what it does. It helps others understand the code. Writing effective docstrings requires thoroughly reading and understanding the code to accurately describe the function's purpose, which could be quite time-consuming. And then, after attending a roundtable with data and computer science experts, my mentor and I received suggestions on best practices and identified missing documents. We created a code of conduct, which works as a rule book for contributors and a contributing MD file with guidelines on how they could contribute to the PDB repository. Every GitHub repository should have these files. And then another thing I managed to do was successfully close issues on GitHub. Issues were created for bugs, improvements, or suggestions, and closing them marked their completion. The issues I closed focus on code documentation, enhancements, and bug fixes. This contributed to my personal goal of closing as many issues as I could. And the other thing I did was I wrote a notebook as part of the tutorial describing and explaining an additional option available to the user when curating their dataset. Overall, my work will be used to make the code more maintainable, and now since there's proper documentation, that'll be possible. And also the GitHub repository now has everything that is needed. So with my work, the plan is to submit the code base of PDB Clean for code review and to use the documentation I implemented to help with code maintenance. If I had more time, I would have definitely loved to include more new functions, features, and improvements. So there were several key skills I gained, like learning to work with GitHub, which gave me exposure to the world of collaboration. I learned to work with Jupyter Notebooks, which is essential in data science, and I improved my knowledge in Python since the project was mainly in Python language, and Python is heavily used in the tech industry. There were some challenges I had to overcome, such as relearning biochemistry, but the PDB website and my mentor provided me with amazing resources. There was also tackling Python. I am still new to Python, and there were several functions which I didn't understand, but once again, my mentor and videos helped a lot. Then major successes was successfully cleaning up the code and writing docstrings for it, as well as solving as many issues as I could, which improved the whole code base overall. And then my main takeaway was that I finally decided to solidify my choice to major in data science. I would like to thank my mentor, and then the Michael Levitt Lab, Sophia and Amanda, as well as the SLI team. Thank you.
Thanks, Paulina, for kicking it off for us. We are going to move on to Christian. So I'm gonna stop sharing. Christian, you can go ahead and share your screen while I introduce you. So Christian Polito is a returning student